Hi everyone, I'm Crispy Rio from BStat1A, and in this video, I'll be discussing the different types of functions. Three different types of functions: injective functions, surjective functions, and bijective functions. So, the first I'm gonna deal with is the injective function, also known as one-to-one function. Why so? Because for every one input, there's only one output. So for every input, there's a unique output. That is very important because all the elements in the domain have been used. So here's the domain or input values, and all the elements in the domain have to be used in an injective function. But all the elements in the code domain do not have to be used. As you can see here, that 8 is not used, but this is an injective function because all of the inputs have unique output. By 3 to 7 and 5 goes to 9 and 7 goes to 11. Injective function must only cut graph once in horizontal line test. And now you look also a test for injective functions is if you draw a horizontal line across to the graph. For an injective functions, for horizontal line can only cut the graph once. Now, the next type of function is a surjective function. Every element in the code domain, here is the code domain, is the image of at least one element in the domain. Okay, so look at the difference between H and the injective function. This is a surjective function. A goes to F, but B can also go to F. They don't exactly to have unique and output. C goes to G, D goes to H, and E go to I. And now, all of them the code domain has been used. So, this is very important in a surjective function. The range is equal to the code domain because every single value in the code domain has been used to range every single input as the use of all of the possible outputs or all of the elements in the code domain. Now for a surjective function, and use the horizontal line test again. Now both of these graphs are surjective functions. This is surjective function because the horizontal line cuts the graph at least once. Okay? Now I know that I said for an injective functions a code equals once, but this go at least once. These also are surjective functions because the horizontal line cuts at least one. As you can see there, once, twice, and 3 times in this particular function. Now moving on to our next types of functions, which are bijective functions. Now, bijective function is a function which is both injective and surjective. These functions are one-to-one functions, but every element in the code domain is used. So remember when the conditions for surjective function was every element in a code domain used. Okay, so a bijective functions, if asked to describe the functions, see by its bijective and looked if it is both injective and surjective. Among what's very important, surjective is also to make sure that the range is equal to the code domain. Now, there's a very good example down here. State whether each of the following mapping A to B are 1 functions, 2 injective functions, 3 surjective functions, and 4 bijective functions, and give a reason for your answer. So, a graph number 1. The first thing you are asked, is it a function? Okay? So, every input have just one output. Just another way to describe is in A. There's only one arrow going from each element in A, and yes, there is. So, it's a function fn, and only one arrow from each element in A. Number 2. Is it injective? So, for every input is the unique output, and yes, there is it maps to one element in B. The reason is each element A maps to only one element in B. 3. Is it surjective? First, surjective, and all of the elements, the codomain have to be used. Okay, so the range and the codomain have to be the same, and the range of codomain in this part are not the same, because that's the range, and that's the range where the lines connect. And the last one, is this a particular bijective? The answer is no. So not bijective. The reason for that is because it's not injective and surjective. Remember, to be bijective, the functions is being injective and surjective. So moving on to part B. Yes, it's a function, because only one arrow from each element in A, and it's injective, because each element A maps to only one element in B. It is also surjective. Remember, the range and codomain must be equal, okay? So it's surjective, as you can see that the range is equal to codomain. A part C over here. So it is a function first of all, and we follow the line across one line coming from each element in A. So part 1, there is, yes, it's a function. And not an injective, as two elements in A share same element. Not also surjective, because range is not equal to codomain. And lastly, not bijective, because it's not injective and surjective. That's very important example, as you will see when you go on exercise. That's all. Thanks for watching, and God bless everyone.